Okay, simultaneous equations. So sometimes in the exam they will give you two equations and they'll say solve for x and y. Sometimes in an exam they'll say that two things happen with different results. So for example, bloke goes into a fish and chip shop and he buys 2 pieces of cod and 3 portions of chips, and it costs him X amount of money. And the next day he goes in and he orders something different and it costs a different amount of money. How much of the fish, how much of the chips? So that's a simultaneous equation. Or you get two equations where x and y, or a and b, give a result, and then x and y and a and b, or a and b, give you another result. So, and you then play one equation against the other. Okay. Now, out of habit, I always tend to lose, in this case, the y's, but whatever is in here, okay, 99 times out of 100, unless these are the same, okay, and even then I might still go for this. The reason for this is because if you're going to have a sign change, it's going to be in here, okay. So, being a creature of habit, I like to do things the same way every time. So the first thing that I do is I make y's the same. Okay, now in this case we've got 1y and 1y, so that's fine. Okay, so the next thing I want to do is get rid of the y's. Okay, because if I get rid of the y's, then I'll just have x's and numbers. And that's what I want. Okay, I want to find out what x is so that I can then put it back into one of these equations and then find out the value of y. Okay, so this is always done the same. Well, for me it is. I always make the y's the same and I always get rid of the y's. Okay, now we've got plus y and plus y. If I add these two equations together, plus y gives me 2y. That doesn't get rid of them. If I've got plus y and I take away plus y, the y's disappear. Okay, and that's what I want. So on this occasion I'm going to get rid of the y's by subtracting. Okay, now because I do it the same way every time, I have a rule which is that if the signs are the same, then I subtract. Okay, so if I've got plus 4y, I take them away. If I've got minus 3y and I take away minus 3y, they disappear. So if they're the same signs, I take them away. If they're different signs, then I add them. So if I add a plus y to a minus y, one will cancel the other one out. Okay, because I want 0. So this is the reverse of what we would normally do, where you have same signs always give you positive, different signs always give you negative. Because we want 0, we're going to do the opposite. Okay, so What I'm going to do now is just literally take one equation from the other. So 3x minus x gives me 2x. The y's disappear. 7 take away 3 gives me 4. So if two things cost me 4 quid, one thing cost me 2. Okay. So now I know what x is. So now I want to find out what y is. Just a tip, always go for the all positive equation. Now both of these are all positive, so it doesn't matter which one I use. So I'm going to use this one. It'll work on both, but I'll use this one. And I'm going to find y. So I now know that x is worth 2. So if I've got 3x, I've got 3 lots of 2, which is 6. Now I write the rest of that equation. Plus y equals 7. Okay? This number will always come over here, and remember the sign changes. So y equals 7 minus 6, so y equals 1. And there we go, we found what x and y equals, okay? But we always make the y's the same, and then we get rid of the y's by adding and subtracting. Once you've done those two things, the thing solves itself, okay? So I'm just going to pause this and write another question. Okay, so we've got another equation, or another two equations. So make the y's the same. They're both 2y, that's good. They're the same sign. So I'm going to take them away. Okay, because if I added them, I'd have 2y plus 2y, which would give me 4y. It is of no use to anybody. So 4x take away x is 3x. 2y take away 2y disappears. 16 take away 7 is 9. Okay, make sure that you remember to take the numbers away as well. So 3x equals 9, so x must equal 3. Okay, so I found out what x equals. Can go to either of these equations, so I'll go to the bottom one this time just to make a change. So I can substitute in a value for x. So x is 3, so instead of x I can now write 3 plus 2y equals 7. This number will always come over the other side. So 2y equals 7 minus 3. So 2y equals 4. So y equals 2. And there you go, we found x and y. What some people do is they get so excited at finding an x value that they think, oh, I've done it. Okay, but you've got to go back and find the y value. Okay, so we'll look at another one. Okay, so we've got another one. So make the y's the same. Well, we've got 3y and we've got 3y, so that's fine. Now we want to get rid of them. Now the signs are different. So if I add 3y to minus 3y, the 3y's will disappear. So this time I'm going to add. Okay, remember the signs are different. Okay, this is why I lose the y's, because if you get a sign change, it happens in here. Okay, and we don't really want to get involved with minus things. Okay, so we're going to add these two equations together. So 5x plus 2x is 7x. Plus 3 added to minus 3, it disappears. 23 plus 5 is 28. So 7x equals 28. And then x must equal 4, because 4 7s equal 28. So I now know the x value. Now I could go to this equation, but I've got minus 3y, and I don't really want that. I want to make life easy, so I go to the all positive equation. So if x equals 5, 5x is 5 lots of 4, which is 20. And then I write the rest of the equation, plus 3y equals 23. As always, the number comes over. So remember the sign change. So 3y equals 23 minus 20. So 3y equals 3. So y equals 1. Just one other thing, because you know this number is coming over here, don't try and do this all in your head, okay? I know you probably could, but in the exam, the examiner wants to see all of these steps, okay? So it is important. Okay, so I'm hoping that you're starting to see now how we do this. Okay, and you can always pause and then do it and then see if I've got the same answer as you. Okay, so we'll do the next one. Okay, so we want to make the y's the same. Now we have a 2y and a y, not the same. But what I can do is make this y 2y by multiplying it by 2. Okay, and that means I have to multiply the whole equation through by 2. Okay, so we have 2 times 3x is 6x, 2 times y is plus 2y, and 2 times 7 is 14. Okay, so I'm not interested now in this equation. Okay, now I rewrite this first equation. So I have 4x plus 2y equals 10. Okay, so this equation, again, it still will work, but I've no interest in it because it's y and not 2y. And the other thing as well is, supposing I'd written 4x plus 2y equals 10 over the top of this. Okay, now the signs are the same, so I'm going to take one equation from the other. If I had the 4x on the top, if I have 4x take away 6x, I get minus 2x. I don't want minus 2x. So it doesn't matter which way round you have the equations, make it work for you. Okay? Probably for a lot of your life, maths has controlled you. Now you control the maths. Okay? So I rewrite this so that I don't get negative x's. Okay? So as I said, this 2y plus 2y will give me 4y. That's no good, so I need to take away. So 4x take away 2x is 2x. 2y take away 2y disappears. 14 take away 10 is 4. So x equals 2. Now I can go into any one of all these equations, okay? I'll just go with the top one because they're all positive. I'll just go with the top one because I can. So if x is 2, 4x is 4 lots of 2, which is 8. Then I write the rest of the equation, plus 2y equals 10. As always, the number comes over the other side, so we get 2y equals 10. Remember the sign changes, so we get minus 8. So 2y equals 2, so y equals 1. And there we go, we solved it. Okay, so it really isn't that difficult. It's make the y's the same, and then it's just add or subtract the equations. Okay, so I'll do one more. Okay, so we have these two equations. We're not afraid of them anymore. So we want to make the y's the same. Now I can't make 3y 2y, and I can't make 2y 3y. So I need a number that 2 and 3 both go into. Sorry, excuse me. So 2 and 3 both go into 6. So I'm going to make these 6y. So to make this 2y 6y, I'm going to need to multiply the whole equation through by 3. And this one, to make 3y 6y, I need to multiply that by 2. Okay, this is all totally legal, it's all totally okay. As long as you multiply it all the way through, everything is fine. So 3 times 6x is 9x. 3 times 2y is 6y. 3 times 22 is 66. Okay, now at the bottom, 2 times 2x is 4x. 2 times 3y is 6y. And 2 times 6 is 12. Okay, so now, albeit 1's plus 1's minus, we've got 6y's. Okay, now the signs are different, so I'm going to add the two equations, because if I add 6y to minus 6y, they disappear. So 9x plus 4x is 13x, and 66 plus 12 is 78. Okay, so 13x equals 78. Okay, so x equals, now 13 into 78, well, 5 times 13 is 50, is 65, not enough. So if I go 6 times 13, 6 10s are 60, 6 3s are 18, 60 and 18 is 78. So x is 6. Okay. And usually this sort of question would probably be on a calculator paper anyway, so you wouldn't need to worry about that. So now I can go to any of these 4 equations, okay? But I want an all positive one, and I want an easy one, so I'm going to go into that one. So if x is 6, 3x is 3 lots of 6, which is 18. I write the rest of the equation, so plus 2y equals 22. As always, the number comes over the other side, so we get 2y equals 22 minus 18. So 2y equals 4. So y equals 2. job done. Okay, so the key is make these y's or whatever is in here the same, add or subtract, find x, substitute it into an all positive equation, bish bash bosh, job done. Okay, so what looks horrible often isn't. Okay, so I'll move on to something even more spectacular.